When we talk about molecular polarity, we want to draw a picture of the molecule, and that's what we're going to do today. We're going to draw molecular pictures, and from that, you're going to try and visualize, you're going to try and interpret what the drawing looks like, what this drawing looks like. The drawing is either going to be polar or non-polar, and the rules that we're going to use is you draw a line down the middle. Is it the same left and the same right? If that doesn't answer the question, you're going to draw a line left to right. Is it the same top and is it the same bottom? So, just to give you a quick example of that, look at a water molecule. A water molecule we're going to learn today is bent. A water molecule looks like this. There's 2 electrons here, 2 electrons there. So now if you look at this and you draw a line down the middle, what is your conclusion? That it's a non-polar molecule, because to the left and the right are the same. But you have to do a second test. The first test is a straight line up and down. The second test is a horizontal line. Now you ask the question, is it the same top and bottom? See, they're different. This has 2 hydrogens on the bottom, no hydrogens on the top. So this is called a polar molecule because it is non-symmetrical. So I don't want to spend too much on this because I want you to be able to visualize this with the models that we're drawing. Some models are going to be like this, and you'll hold it up and you'll see it's non-symmetrical. It doesn't have this completely balanced configuration. Some of the molecules you're going to hold in your hand, they're going to be totally balanced, and you say, wow, that's a non-symmetrical, that's a symmetrical model that is non-polar. So symmetrical models are the non-polar. The word symmetrical is a fancy word for, they have a balanced picture pretty much. The picture is balanced. Left side, right side was the same, top and bottom were the same. That's what I mean by a symmetrical. Non-symmetrical would be all of these polar things are non-symmetrical. So we're going to talk about molecules in the course of the laboratory, but I want to talk about bonds now. I want you to understand there are 2 separate matters. One of them is bond polarity, which is the difference between 2 atoms and 2 atoms only. Molecular polarity is the polarity of the entire group of atoms brought together in a molecule, right? So bond polarity has to do with the difference in what we call electronegativity. Fancy word for electron loving. Which atoms on the periodic table are the ones that donate electrons? Metals. So where are they located on the periodic table? They're on the left side, right? They're over there. So if they are the ones that donate electrons, they give away electrons, do you think they are electron loving? They're probably not. So then, which group on the periodic table would be electron loving? The non-metals. So the non-metals are electronegative, and that's what we use it for, electron loving. They love electrons, and therefore they want to accept them from any source, from any other atom. If these are on if these atoms on this side of the chart, the non-metals over here, if these are so-called electronegative, I wonder what they call the ones on the other side. They must be electropositive. Okay? That makes sense, because at the end of the day, when you write the structure for sodium ion, it's Na plus, and it's a positive charge. When you write the structure for chlorine, it's Cl minus. Okay, that means it's electronegative. So it's the concept is very, I think it's pretty simple to relate. Now, a man by the name of Linus Pauling, he was the one who came up with the structure of vitamin C. He also came up with this table. He said, using the word electronegative is okay, but you don't answer the question, how electronegative is it? You know, how short or how tall is a person? You want to know some dimension. You want to know, can I put a number? Can I assign a number to this term, electronegativity? So Pauling came up with a set of numbers, and this is the periodic table, drawn in a little different manner. The electronegativity values were assigned from 4 is the maximum, and fluorine, being in the upper right-hand corner, is the most electron-loving element, or electronegative element, and he gave it the number 4. He could have given it the number 100, it doesn't matter, they're relative numbers. He picked the number 4. The least electronegative element is rubidium, all right? Now that's not entirely true, but those are the ones that we are responsible for in this class, are we not? We're responsible for a group of elements up to 56. So typically these are the ones we're going to work with in this class. We're not going to worry too much about the guys in the middle here. You do not have to memorize these. These are numbers that will be given to you on a quiz, or in fact you may be given a picture of that chart. On the final exam, you will have a picture of that in your exam booklet as a reference page, okay? So these are numbers that are assigned, and this will allow us to say how electronegative is fluorine, for example. Well, fluorine is a number 4. See it? Boron is a number 2. So how much more electronegative is fluorine than boron? It's twice as electronegative. It's double the electronegativity. Now, that's fine because we're only talking about single atom. Fluorine is 4, boron is 2. But what happens if I join together a boron and a fluorine, and I join together a boron and a hydrogen? And I want to know which of those 2 bonds, remember we're talking about bond polarity, which one of those 2 bonds has the strongest bond? The strongest bond means which of these bonds is most polar? I'm looking for highest polarity. Which one has the highest polarity? Polarity means which one has the strongest bond. Now, strength of a bond has to do with, hold my hand here, hold my hand. Strength of a bond has to do with, we're both fighting one another here. This is what a covalent bond is all about. You're trying, each one is pulling in each direction. Now, which one of those is going to pull the electron harder? The hydrogen, the boron, or the fluorine? Always fluorine. Why? Because it's the most electronegative. So everything else is going to be less than that. So in this fight of who's going to hold the electron, who's going to pull the bond tightest, this bond should be the strongest because it has fluorine in it. Now, that's a good guess, but now we can assign numbers to it. We can say this is a 4 and boron is a 2. We know boron is a 2. Hydrogen is a 2.1. So what we're interested in now is which one is the strongest. Now we have a way of assigning a number to it. The number is the difference between those 2 values. And we don't use negative numbers, no negatives. So just take the high number and subtract it, take the low number and subtract it from the high number.